In this video, I want to give you some examples of weak and strong acids. You should be able to list the common strong acids because once you're able to memorize those, anything else that you see donating a proton, it's going to be a weak acid. And we're also going to differentiate weak and strong acids. So let's start with that one. Okay, so weak versus strong acids is not necessarily related to their pH. A strong acid does not mean that it's going to have a lower pH. What weak and strong mean in terms of acids is how well it's able to donate a proton. Because if we remember our definition of acids, they are proton donors. So a strong acid is going to fully donate, and the weak acid is only going to partially donate. It's going to waffle back and forth in its equation. It's not going to just like completely disassociate in water. So a strong acid will fully dissociate in water. A weak acid will only partially disassociate that in water. And one of the ways you can tell is by looking at the arrows. So here in this first example, I've got just the generic acid, HA. And we see this arrow, which looks like this. It's a solid arrow going to the right. That means 100% after this hits water, 100% is going to be on the product side of the reaction. So this is going to be a strong acid. The weak acid is going to wiffle waffle. It's going to go back and forth. So we're going to have an arrow going to the product side, but some of it's going to go back to the reactant side. So this is not going to be 100%. And the actual like partial movement here, that's something called the pKa, which we're not going to discuss in this video. Okay, and so one of the other things that you might be wondering is kind of like when we write these out, what is exactly happening here? Well, here we can see the HA dissociate into H+, that's our proton that's donated, and A-, just like this H goes there, this A goes there, and H2O goes right there. So that's all well and good. Let's change that to stroke eraser. There, that's a little bit better. But that's not how we write them in class. So how we write them in class would be like HA plus H2O yields H3O plus A-. And that's because what we're doing is combining this H plus with this H2O, because water's able to pick it up. Water's got a neutral pH. It can act as either an acid or a base. Weak one at that. So that's what's going on there. So you'll probably see it, see acid equations like this, if it's strong, and then just with the strong arrow. And weak, it's the exact same thing. It would still be HA plus H2O, weak arrows, wiffle waffling, and then that's making H3O plus A-. I just kind of wanted just to break it down for you so you could see where that is. Okay, so how are we going to know what's strong acid and what's weak acid just by looking at the formulas? Well, there's just a handful of strong acids that we need to memorize. So let's go through that really, really quickly. One you should definitely know is hydrochloric acid. That's HCl. Hydrochloric. We've also got nitric acid. And if you notice in the names, they've all got the word acid. That's a big indicator that they're, in fact, an acid. For H2SO4, you notice that there's two H's here. Only the first one, the first H that comes off is strong and will go 100% as soon as it hits water. But the second one will not. So this is sulfuric. We've got also hydrobromic acid and hypochloric acid. Those are a little bit less common. You should definitely know the top three. Weak acids, on the other hand, that aren't going to go fully to completion, they're going to wiffle waffle, some as product, some as reactant, they're not going to fully disassociate. Those are going to donate that proton for sure, but they're not going to be one of these strong acids on the list. So if they're not one of these, but still donating a proton, it's a weak acid. So things like vinegar, things like citric acid, things like that, those are weak acids. So now let's look at these. Okay, so here's some examples, and feel free to pause the video and try these for yourself. Identify if these are weak or strong acids. So I'm going to go through real quick and just underline the proton that's going to be donated. I'm not tricking you here. There. So that's the proton that's going to be donated. So these are all, in fact, acids. First one, it's on the list, so that's going to make it a strong acid. Pen problems. Strong acid. Okay, second one, HCOOH, that wasn't on the list. That's what makes it a weak acid. So this one is actually formic acid. I spelled weak wrong. That's weak. CH3COOH, donating a proton, not on the list. That's what makes it weak. This is acetic acid. That's vinegar. HNO3, that's on the list. That's strong. It's nitric acid. Try to spell nitric as part of strong. Not my best day, guys. And then HF. This one is weak. Even though it's very close to, even though fluorine is really close to Cl on the periodic table, it's because it's smaller, it's going to hold its electrons a little tighter. It's going to hold the proton a little tighter, so it's not going to fully dissociate in water. Hope this has been helpful. Best of luck on your exams.